Hello friends, welcome to Easy Maths. We are going to learn about fundamentals of sequences and series. So this is a continuation video of our part 1. So in our previous video, we discussed about the idea of sequence and the sum of the first n term of a series. In this tutorial, we are going to discuss about the arithmetic progressions. So under arithmetic progressions, we are going to learn two parts, which are formula for the nth term and formula for the sum of the first n terms. So let's have a small description about the arithmetic progressions. So arithmetic progression is a sequence of numbers such that any two successive terms differ by the same amount, called the common difference, and which is denoted by D. Example: 2, 5, 8, 11, 14 is a sequence which has a difference of 3 for each terms. So if you consider the next sequence 15, 10, 5, 0, -5, the difference is -5. Formula for the nth term. Suppose we consider the arithmetic progression 3, 6, 9, 12, and 15, and which goes on. The common difference is 3. The first term a1 equals 3, the second term a2 equals 6, so which can also be rewritten as 3 plus 2 take away 1 times 3. So we write in this way in order to get a general formula for the arithmetic progression. So which equals a1 plus 2 take away 1 times d. So the third term a3 equals 9, which equals to 3 plus 3 take away 1 times 3, a1 plus 3 take away 1 times d. And it goes on for a4, a5, and so on. So therefore we see that the common term an equals to a1 plus n take away 1 times d. So the nth term of an arithmetic progression is given by the formula an equals a1 plus n take away 1 times d, where a1 is the first term and d is the common difference. Alright, so let's apply this formula in some questions. Example 1. Find the first three terms of an arithmetic progression in which the 10th term is 10 and the common difference is 2. So the general formula for the arithmetic progression is an equals a1 plus n take away 1 times d. So which is the formula for the nth term of an arithmetic progression. So we know. So let me underline the important keywords. So we need to find the first three terms, and the 10th term is 10 and the common difference is 2. So A10 equals 10 and D equals 2. So if we apply those values in the equation, A10 equals A1 plus 10 take away 1 times 2. So if you simplify or if you apply the other values as well, you can get 10 equals A1 plus 18, and by simplifying, you can get that A1 equals -8 and A2 equals -6, and then A3 equals -4. So once we got A1, we can take away. So in this case, the first term is -8. So the common difference is 2. So we are adding 2 with each term. So A2 add 2 would give you A3, which is -4. So let's move on to the next example. Example 2. If an equals 20, a1 equals 5, and d equals 3, how much is n? So here we are asked to find the value for n. So we apply the same formula an equals a1 plus n take away 1 times d, and an, which is the final term, equals 20, and the first term is 5, and then n take away 1 times 3. So if you simplify, you get 15 equals n take away 1 times 3, n take away 1 equals 5, where you have divided both the sides by 3 in order to get rid of the 3 which is attached with n take away 1. So by simplifying, we can get n equals 6. Okay, friends. So let's try this question. Find the 12th term of an arithmetic progression in which the first term is 12 and the common difference is negative 3. So let's start by underlining the important keywords. So the 12th term of an arithmetic progression is what we need to find out. And the first term is 12 and the common difference is negative 3. So the general formula for the nth term of an arithmetic progression is an equals a1 plus n take away 1 times d. And we are going to substitute these values. So if it is the 12th term, so then a12 equals 12 and the common difference d equals negative 3. So if you substitute those values, you'll be getting an equation like that. And then by simplifying, you get 12 at 11 times negative 3. Further simplifying would give us 12 take away 33, which equals to negative 21. So the 12th term of the arithmetic progression is negative 21. Exercise 2. Find the first four terms of an arithmetic progression in which the first term is 8 and the common difference is 4. So the first four terms of the arithmetic progression is what we need to find out. The first term is 8, the common difference is 4. So we are going to use the formula which is an equals a1 plus n take away 1 times d. So we know a1, the first term is 8 and the common difference is d. So by substituting these values on the equation, we get a2, the second term, which equals to 8 plus 2 take away 1 times 4, which equals to 12 at the end. So the second term is 12. And if you substitute for a3, which is for the third term, you'll be getting 16 as the answer. And so on for a4, you'll be getting 20. So you can directly get the answers without using the formula also by adding 4 each time starting from 8. So 8 at 4 is 12, 12 at 4 is 16, 16 at 4 is 20, since we are asked to find only 4 terms of the arithmetic progression. Exercise 3. If a4 equals negative 2 and a8 equals 18, what is a12? So for this question, we do not have the first term, we do not have the common difference. But without those values, we cannot find out a12. So what we are going to do here is to apply the equation, and we are going to have two equations which would resolve to give us the first term and the common difference d. So we know a4 equals negative 2, so which is the fourth term. So we are going to derive an equation for that. So a4 equals a1 plus 4 take away 1 times d. So a4 equals negative 2. Negative 2 equals a1 plus 3 times d. So which is the first equation. And then we are going to derive an equation for a8, which is the eighth term. That would give us 18 equals a1 at 7d. Now we have a1 and d in both the equation. So first we'll get rid of either a1 or d. So I have taken away a1 from both the equations by taking away 1 from the second equation. So the second equation take away the first equation would give us 18 take away negative 2 equals 7d take away 3d. So 18 take away negative 2 would change into 18 plus 2, which would give us 20, which equals to 4d. So by dividing both the sides by 4, we would get 5 as the common difference. So once we got the difference, we can substitute d in the equation 2 to get 18 equals a1 plus 7 times 5. So which would give us 18 plus, 18 equals a1 plus 35. So a1 equals 18 take away 35, which equals to negative 17. Now we know the first term and the common difference. By substituting them in the formula for the nth term of the arithmetic progression, we can find out the 12th term, which is a12. So a12 equals negative 17 plus 12 take away 1 times 5. So negative 17 plus 11 times 5, which equals negative 17 plus 55, which equals to 38. So the 12th term of the arithmetic progression is 38. Exercise 4. How many numbers are there between 20 and 70 which are divisible by 3? So if it is how many numbers, we need to find the value for n, which are in between 20 and 70, which is divisible by 3. So we know that 20 is not divisible by 3. So 21. So 21 is divisible by 3. So that is the first term of this sequence. And we'll be finding the last term of this sequence. So 70 cannot be divisible by 3 without any remainders. So 69 is another number which is divisible by 3. So 69 is the last term of this sequence which is divisible by 3. So we use this information. So the first term is 21 and the common difference is 3. An, which is the last term of this sequence, which is 69. By substituting these values in the formula for the nth term of the arithmetic progression, we get 69 equals 21 plus n take away 1 times g. 69 equals 21 plus 3n take away 3. So we got 3n take away 3 by resolving the brackets. And 69 equals 18 plus 3n. By taking away 3 from 21, we got 18. And we are dividing both the sides by 3. So this is to get rid of the 3 which is attached with the n. So that would give us 23 equals 6 plus n. And if you resolve that, by taking away 6 from 23, we get 17 as the value for n. So the question says how many numbers are there between 20 and 70 which can be divisible by 3. So the answer is 17. So there are 17 numbers in between 20 and 70 which can be divisible by 3. Okay, friends. So let's move on to the next part of this lesson, which is a very important part for this lesson, which is formula for the sum of the first n term. So we'll be deriving two formulas for the sum of the first n terms. So let's start. Consider the sum of the first n terms a1, a2, a3 to an take away 1 an of an arithmetic progression. So the sum of n terms would give us by adding all the terms of the sequence. So which would give us Sn equals a1 plus a2, a3 plus an. So in between a2 and an we have a lot of terms. So up to an we have the terms. So that can be any numbers, any terms like a2, a3, a4 and so on. And we know that an equals to a1 plus n take away 1 times d, so which is the formula for the n term of an arithmetic progression. So by substituting that formula for each of these terms, so a2, a3 up to an, we get the first equation, which is Sn equals to a1 plus d. So we got a1 plus d by substituting the second term for the nth term of the arithmetic progression. And we'll be getting plus a1 plus 2d and so on, a1 plus n take away 1 times d. So that is the first equation. So the sum may also be written in the reverse order, which is Sn equals an plus an take away d plus an take away 2d up to an take away n minus 1 d. So that is the second equation. So by adding 1 and 2, we obtain 2 Sn equals n times a1 plus an. So this needs to be an. So all the other terms would be taken off from the equations. So that's how we'll be ending with 2Sn equals n times an, a1 plus an. So by dividing both the sides by 2, we get Sn equals n by 2 times a1 plus an. Since an equals a1 plus n take away 1 times d, we substitute instead of an, so we get Sn equals n take away n by 2 a1 plus an, which equals to n by 2 a1 plus a1 plus n take away 1 times d. So our next important formula for the sum of the first n term is Sn equals n by 2 2a1 plus n take away 1 times d. So these are the two equations for the sum of the first n term of an arithmetic progression. So let's apply those equations in some questions. Example 1. Find the sum of the first 16 terms of the arithmetic progression 4, 8, 12, 16, 20. So we know the difference is 4 and the first term is 4. So we are going to substitute those values in the formula for the sum of the first n terms, which is Sn equals n by 2 times 2a1 plus n take away 1 times d. So we are asked to find out the sum of the first n terms, which is the 16. So 16 divided by 2 times 2 times 4 plus 16 take away 1 times 4 would give us the answer as 544 at the end. Example 2. Find the sum of the numbers which are divisible by 6 that lie between 50 and 100. So the first term which is divisible by 6 is 54. And the last term of the sequence which is divisible by 6 is 96. So a1 equals 54 and an equals 96, and the difference is d. So by substituting these values in the formula for nth term of an arithmetic progression, we can get the number of terms which can be divisible by 6 in between 50 and 100. So that would give us 96 equals 54 plus 6 times n take away 1, which would give us 8 for n. So by substituting n equals 8 in our equation or the formula for the sum of the nth terms of a sequence, which is Sn equals n by 2 times a1 plus an, we can get an answer of 600. So the sum of the numbers which are divisible by 6 that lie between 50 and 100 equals 600. Exercise 1. The fifth term of an arithmetic progression is 14 and the 11th term is 26. Find the sum of the first 15 terms of the progression. So let's start by underlining the important keywords. The fifth term of the arithmetic progression is 14 and the 11th term is 26. So we are asked to find the sum of the first 15 terms of the progression. So if it is fifth term, a5 equals 14 and we know a11 equals 26. But we do not know the first term or the common difference. So we are going to apply those values in the equation. An equals a1 plus n take away 1 times d. So by substituting for the fifth term would give us a5 equals a1 plus 5 take away 1 times d, which equals to 14 equals a1 plus 4d, so which is the first equation. So now if we make another equation for the 11th term, a11, we can get a11 equals a1 plus 11 take away 1 times d. So that equals to 26 equal a1 plus 10d, so which is the second equation. So by taking away the first equation from the second equation, we can get 12 equals 60. So the A1 in both the equation get cancelled off. So we get 12 equals 60. So if you divide both sides by 6, you get D equals 2. So now we know the common difference is 2, and we are going to find the first term, A1, by substituting D in the equation 1. So 14 equals A1 plus 4 times 2, which would give us A1 equals 6. Now we know the first term and the common difference, and we are asked to find the sum of the first 15 terms of the progression. So now is the time for us to work out for the sum of the first n terms. So the common general equation is Sn equals n by 2 times 2a1 plus n take away 1 times d. So we are going to substitute 15 for n. So that would give us S15 equals 15 over 2 times 2 times 6 plus 15 take away 1 times 2. So by resolving that part, we can get 15 by 2, 12 plus 28, and further simplifying would give us 15 by 2 times 40. The sum of the first 15 terms of the progression would give us 300 as the answer. Exercise 2. An auditorium hall has 40 chairs in the first row. Each successive row has 2 chairs more than the previous row. How many chairs are there in the first 20 rows? How many of the front rows would 376 people occupy? So this question involves some more steps, as there are two questions joined together in this big question. So let's break the question into pieces. So first, we'll underline the important keywords. So the auditorium has 40 chairs in the first row, and each successive row has 2 chairs more than the previous row. So how many chairs are there in the first 20 rows? So that is one question. And how many of the front rows would 376 people occupy? All right, so by drawing a small diagram, we can get a clear understanding about this question, or else we can also have a small description like this. So the first row has 40 chairs. As the successive row get increased by 2. So first we need to find out the number of chairs that are there in the first 20 rows. So in order to do that, we need to use the formula for the sum of the n terms of an arithmetic progression. So the value of the n is 20 here. So if we use that equation, Sn equals n by 2 times 2a1 plus n take away 1 times d, S20 equals 20 over 2 times 2 times 4, 40, plus 20 take away 1 times 2. So that would be simplified to 10 times 80 plus 19 times 2. And by simplifying, we can get S20 equals to 1180. So that is the number of chairs that are there in the first 20 rows in the hall. And we have another question to be answered, so which is how many of the front rows would 376 people occupy? So now we know the total sum, the sum of the chairs in the front rows, which is 376, and we need to find out the number of rows, which is the n. So the same equation, Sn equals n by 2 times 2a1 plus n take away 1 times d, is what we are going to use here. So Sn equals to 376 because that is the total number of chairs, and n is what we need to find out. So n by 2 times 40 plus n take away 1 times 2. So if you simplify, 2 times 40 would give us 80. And then we are multiplying both the sides by 2 in order to get rid of the 2 which is attached with the n. So 2 times 376 equals n times 80 plus 2n take away 2. So also the brackets is resolved as 2n take away 2. So 2 times 376 equals to 78n plus 2n squared. So again, the brackets are resolved by multiplying n for each of the expressions, each of the terms inside the brackets. So that would give us 78n plus 2n squared. So by dividing both the sides by 2, we can get 376 equals to 39n plus n squared. So this is a quadratic equation which we can get as n squared plus 3n, 39n, take away 376 equals 0. So by finding or by resolving the quadratic equation, we can get n take away 8 whole thing bracket times n plus 47 bracket equals to 0. So by finding the solutions for this equation, we can get n take away 8 equals to 0 and n plus 47 equals to 0. So n plus 47 equals to 0 cannot be resolved to get a positive value for the number of chairs. So the actual answer for this question needs to be n take away 8 equals to 0. So by resolving that, we can get n equals to 8. So the number of front rows that would give us 376 chairs, or this 376 people could occupy, is 8 rows. So that's it for this video, my dear friends. So for all of that and more, I will meet you in the next tutorial. Thanks for watching.